Good morning, class. Welcome back to Biomedical Ethics. Today we'll be talking about a growing area in biotechnology, or the do it yourself biotechnology movement, where community members are focused on creating bioart and doing some biohacking or utilizing current biotechnologies to do research in the confines of your home rather in the corporate or university research context. And we'll be talking about all of the ethical, well, not all, but many of the ethical and social implications of this work, as well as potential implications for medical professionals. So class will be structured as follows. First, we'll define our terms. What is the biotechnology do-it-yourself movement? And within that umbrella, what is then bioart and biohacking? Are these acceptable applications of the current research standards that we have, or are they not? Should community members be doing research in contexts where there are no research standards, right? And what are in addition to concerns over scientific validity, et cetera, well, this feeds into the epistemological concerns. What are the epistemological, methodological, and method focused concerns, and the larger ethical and social concerns here? Now, do not worry about that slide. As you all know right now, most of your materials are online. Now, when we think of applying biotechnologies, when we think of work, say utilizing CRISPR, for example, I would dare to say that most students would think of a research context. Biotechnologies are typically applied in the laboratory. They're not typically utilized in someone's sink or someone's basement, for example. But the do it yourself biotechnology movement that began, as we'll see, in 2003 is a push to help individuals access and use biotechnologies in the home or in community labs. And this has been a growing movement that we're seeing all around, not only in the United States, but in international communities as well. And they're utilizing these technologies to not only improve STEM education purposes, uh, but also for two activities that are typically called biohacking, which connects with the human enhancement discussions we're going to be talking about on Wednesday, and bioart. But I'm getting ahead of myself. So the do-it-yourself biotechnology movement largely grew out of the field of synthetic biology. Synthetic biology is a field of scientific inquiry that involves redesigning organisms, or the building blocks of nature, for useful purposes by engineering them to have specific abilities. Synthetic biology researchers and companies as well around the world harness this power of nature to solve problems in medicine, manufacturing, and agriculture. Now, do it yourself bio largely grew out of iGEM contests, or international genetically engineered machine contests. Uh, in these sort of tour de forces, university student teams compete to make synthetic systems that work in living cells. And Kelty, one of the top scholars working on analyzing this do-it-yourself biotechnology movement, argued, quote, iGEM contests have probably done more than any other event to create a generation of biohackers, end quote. And biohackers, it sounds like a cool moniker, right? Like t-shirts, be like, what? You know? Now, iGEM students began the garage biotechnology movement as the cost of DNA sequencing and the material and tools necessary to do so largely declined. So in 2001, Robert Carlson predicted that as the technologies become less expensive, faster, and simpler to use. You don't need a PhD in some contexts. They would move from academic labs and large biotechnology companies to small businesses, and eventually we're going to see DNA sequencing and synthesis, etc., in the home garage, in the kitchen. So Carlson states that the era of garage biology is upon us. Want to participate? Take a moment to buy yourself a molecular biology lab on eBay. That year, Carlson was the first to build a lab in his garage, completely with materials that he purchased off of other people online, and for a relatively small price tag as well. So, with the rise of the garage biology movement or the do it yourself biotechnology movement, um, there are two other terms that we should discuss that sort of come up in conversations about this shift to remove biotech research from the large lab, the academic lab, and from large companies to home garages, etc. Bioart is defined as the practice where humans work with live tissues, bacteria, living organisms, and life processes for aesthetic purposes in order to make a statement or to develop an artistic project. Whereas biohacking is an activity or the activity of exploiting genetic material experimentally in your garage, etc., free from standard norms. Many of the current biohackers argue that this freedom can help develop creativity. Well, this freedom can help harness the creativity of the masses in order to push forward biotechnological innovation. But there are concerns that bioart and biohacking is just a slippery slope down to another practice, which the FBI and the United States, the United States forces, police forces, etc., don't look kindly on. Bioterrorism. Bioterrorism, as we'll see, is something that a few biohackers have been charged with. Now, bioterrorism is called, it's the intentional release of biological agents such as bacteria, viruses, or toxins that may be naturally occurring or are in a human modified form, but that could cause great harm to populations and negatively impact public health, which, by the way, is a crime. So we have bioheart, utilizing said technologies for aesthetic purposes, biohacking, utilizing said technologies in the context of your house, typically for research purposes and or for enhancement. And then we have the concerns that such utilizations could equate to bioterrorism. So the do-it-yourself biotechnology movement, the garage bio movement, so to speak, is an offshoot of the maker movement. And I'm not sure if you're aware of the maker movement. You oftentimes see these spaces in cities. There's a maker space in San Francisco, for example. There's one in, well, there's several in New York. There's one in Seattle. I visited one as well in Las Vegas. So they're all around. So the maker movement is an umbrella term for independent inventors, designers, and tinkerers to come together to pool their money, to share, to buy expensive equipment that will help them in their endeavors, but then place this equipment in a shared context where you know, have a small monthly fee, and then you're able to utilize 3D printers, welders, etc., in order to work on projects. Now, the maker movement is slowly moving into embracing biotechnology and do-it-yourself, the do-it-yourself bio biotechnology movement, the garage bio movement, sort of also comes out of this maker movement to create spaces, but not just for 3D printing and welding, etc., and for tinkering and inventing, but also to do biotechnology research. So, do it yourself biohacking is where individuals with little or no training perform biology experiments utilizing the same methods as traditional research institutions. And indeed, the maker movement, not only can you rent spaces in order to do said research, but sometimes they also have another novice there providing educational opportunities to help train populations on how to perform said research. So, do it yourself biohacking then could be utilized, and it has been argued, as we will see, or at least in the material for the week, that do it yourself biohacking is an excellent educational opportunity. We're putting wet labs or laboratories in communities. We're training children and young adults in research methods and methodologies. We're helping spark interest in STEM and, in the case of bioart, STEAM education. This is a wonderful way to fix the leaky pipeline and move students who are interested into scientific fields, right? And so this is seen as a positive development for educational purposes. It's also given rise to a wide range of new artistic projects that are increasingly being shown in museums. Biotechnology can be utilized for many purposes, and why not harness it for artistic expression as well? But then there's also questions concerning human enhancement. We could or utilize these labs in order to make modifications, as we'll see, in ourselves and others. And supporters of that argue that this is helping to kickstart innovation, or detractors are arguing that this is dangerous because we have people who are not trained and we have no ethical standards in place. Currently in California, for example, legislators are determining whether or not standards should be put into place for this movement due to the rise in its popularity. All right, so what is bioart? I'm going to show you a brief clip just of some bioart projects, although there are a whole host of videos on YouTube. I sort of recommend to go down that rabbit hole, but I sort of don't recommend to go down that rabbit hole, so it is completely up to you. So bioart explores the boundaries between biological processes and tissues and artistic expression.
People have always argued about what I do is or is not art. It's a contest with the harsh and chaotic forces of nature. Nature is Moby Dick. She's not always very nice.
This ear is not for the artist. The artist already has two good ears to hear with. But it's an ear for people in other places.
Les cellules les plus jeunes, les plus fortes qui gagnaient et qui bouffaient les autres qui mouraient. C'est extrêmement violente.
Everything I do, I'm approaching as an artist, and even the way I learn the procedures is in the way a hacker learns to program computers.
Okay, so that's just an example of some of the bioart projects that are currently occurring in that have occurred in a museum context in Germany. Now, the biohacking movement is also, or the do-it-yourself biotechnology movement, although I'll just call it the biohacking movement, is also built on a clear ethic called the hacker ethic. And this is built on the idea that we should be sharing technological innovation, that scientific inquiry is not for the elite. It's not simply for those who can afford incredibly expensive equipment. Well, as we're seeing the prices going down, but it should be for everyone. Everyone should be engaging in scientific inquiry. It should be seen as a citizen science. So it's built on sharing, openness, the decentralization of knowledge, free access to computers and technology that's needed for inquiry, and this is seen as a way to harness information, and harness a scientific inquiry so that we can work on improving the world. We're all socially situated in different ways. We all have different hopes and dreams and problems that we need to solve. By placing technology in the hands of everyone, then we can solve all sorts of problems that might not come to the purview of those who are in traditional research contexts. So it's tech for all and tech for communities. That's also from an epistemological perspective. It's important to remember that do it yourself bio does not represent a new science, but a new way of doing science. It's built on increasing access and not on modifying methods and methodologies. So it's a different way of engaging with science and technology and with the making of things and futures, to utilize Levi Strauss. And there's also a clear demarcation or a clear conflict here between big bio and synthetic bio versus the do it yourself bio movement. DIY bio is pushing back against the larger framing of scientific inquiry that big bio presents. This idea of it being elite or separate from social and community engagement with the world around us. It's also utilizing two different paradigms of knowledge production. So big bio is typically, and this connects to how we're all differently socially situated and we have different problems we need to solve, right? Big bio focuses on increasing profit, right? We're producing profit. So they're highly profit driven. And another focus is on economic productivity. Cells are considered as genetically engineered machines and living factories to create, at least in the synthetic bio context, economically viable materials for the chemical and pharmaceutical industries and the energy sector as well. So if we look at the global market for synthetic biology in the United States, we're looking at it has a very hefty market share of 1.1 billion in 2010. And then in 2006, it was expected to increase and has increased to over 10 billion, with, again, the applications in the chemical and energy context constituting the largest share here. So we're looking at big bio's focus on economic productivity. How can we increase our market share year to year? How could we produce more profits, etc.? Whereas biohackers they find umbrage with that context. They're not interested in economic profitability. They're not interested in market share. And this is precisely why they argue that this technology should be in the hands of community members, because they challenge today's big bio's concentration of power and they want to open up biology to public participation. These processes, these suites, etc., should be utilized by community members in order to address concerns and problems that communities are facing, and not squirreled away or monopolized by large companies that are using them to produce profit and not necessarily utilizing them to address the concerns of the everyday population. So biohackers are not responsive to big companies, but to the communities as citizen science in the making. Do it yourself bio is in search for a fruitful, quote, synergy between technology, development, and community building, end quote. So it's technology for all, and again, technology for community. So we see these different concepts of knowledge production. And in fact, most of the do-it-yourself bio movement pushes back against biotech companies, but they also push back against doing research solely in not only in company contexts, but also in university contexts. Because again, there's privilege associated with being able to perform research in said contexts. And the do-it-yourself bio movement, movers and shakers, so to speak, want to remove any sort of privilege here. And they want to make sure that all of these technological innovations, all of these breakthroughs are in the hands of everyday citizens. So let's democratize creation. And also, there's this push, as we'll see, with as little government regulation as possible. Forget, what could go wrong if we remove any sort of research standards and, any sort of IRB or IACUC approval or process, right? Let's ensure, and just to highlight their position, those things, they limit creativity, like having to do IRB approval. We might not find out the information that we need if we have to go through those sort of processes. To play devil's advocate here and to illustrate what their position is, as we'll see. So in these circles, anyone in the world who has a few dollars can make a creature that changes the game, right? That creates a whole new world. And I'm utilizing that quote because it was discussing the Kickstarter fund to produce glow-in-the-dark plants, which were ultimately, this was ultimately shut down, as we'll see, because no environmental damage assessment was done. You're just shipping plants that have been modified and that can grow in the natural world and can potentially cross-pollinate to individuals across the country, right? But the argument is that we should ensure that these technologies are in the hands of everyone, and they should be utilized for the various purposes that individuals need to utilize them for. And if that includes making glow-in-the-dark plants, then that includes making glow-in-the-dark plants. So rather than a top-down focus on research where higher institutions, companies utilize said technologies, they go through approval processes, safety analysis, and whatnot, and then if they pass all of these hurdles, are introduced into the market. Now let's do a bottom up where communities have access to said technologies. They can utilize them for their purposes, and then they're only pulled if something goes wrong, right? So there are two different paradigms here concerning how knowledge production should be performed. Now, also, and from an epistemological standards or a context, Big Bio utilizes the technology differently in that it produces biobricks, or it focuses on the reduction or elimination of biological complexity by simplification, right, in order to produce various components that could be utilized for a wide range of purposes. Whereas do-it-yourself bio is not so much about the simplification or decontextualization of natural components of the world, but it's about making do, or bootstrapping, so to speak, making do making do with what you have and the limited technological resources that you have, and tinkering with the natural world in order to see what occurs. Now, Claude Levi-Strauss created, or well, not created, but he explored different epistemological structures and different research contexts. And he argued that there are two different paradigms at work here: an engineering versus a tinkerer paradigm. And the engineering paradigm very much captures sort of the epistemological foundations or frameworks of these large big bio contexts, whereas the tinkerer movement is built as a pushback against this engineering concept. So, an engineer typically works utilizing a preconceived plan with a precise goal, desired end, and uses material and tools, etc., that have been designed to help propel you towards that specific desired end. Whereas the tinkerer pushes back against that paradigm, typically working and utilizing material, utilizing tools without a clear plan in order to make creative and resourceful use of whatever materials are at hand to produce new objects that possess some kind of unexpected functionality, end quote here. So he sees the engineering context or the engineering mindset as quite limited, but also very separate from the ethos that permeates what it means to be a tinkerer. A tinkerer is someone who takes a wide variety of materials, utilizes them for different purposes. It's like Zen in the art of motorcycle maintenance. Why am I going to spend $50 for a piece of metal to fix my motorcycle, when I could just cut one out of tin and it will perform the same function? That's a tinkerer mindset, utilizing the materials around you and repurposing them for creative purposes in order to help fuel creativity. Now, there are some key ethical issues that we should discuss here, going back to the initial slide. Is biohacking bioterrorism? Should we be concerned about the possibility of a slippery slope when you place laboratory facilities in neighborhoods and you're not regulating, how they are being utilized? Is this something that we want to do? Does this, on the positive hand, spark creativity and interest in STEM education? And does it help provide or place these powerful biotechnologies in the hands of individuals so that they can utilize them to address community issues? Or is there a real threat here concerning the intentional or unintentional modification of bioorganisms, and that could be harmful to the very communities that these or off-target mutations, etc., but the very communities where these labs are situated. Now, again, bioterrorism, just to note, is terrorism involving the intentional release or dissemination of biological agents. In much so, is this something that should be on our radar here? And should there be greater regulation as well? 2, should biotech research be allowed without regulatory oversight? And we've talked about the ethical standards in place in research contexts for medical research and in medical contexts in general, concerning animals and the use of animals. The 3 pillars of animal welfare, Bernie Rollins' position, Tom Reagan and Peter Singer's position concerning utilization of animals in research contexts. And what about ourselves? So should biotech research be allowed without regulatory oversight to plants, to animals, and to ourselves? And I would add here 3. what are the potential impacts for medical professionals? Is this concerning from a medical context that people are potentially utilizing themselves as research subjects? Three, if we look at biotechnology from a social justice perspective, I misnumbered this. Who should have access to this technology? The do it yourself bio movement is very much built on this idea that it is wrong for such technologies to be in the hands of the few, and that the benefits and harms associated with said technologies are not being distributed in a just manner. Is this the case? Do you believe that? Do you agree with this? Do you think that the do it yourself bio movement is right to move said technologies into the hands of communities? Or do you think that their points concerning social justice are wrongheaded? Where do you stand here? Because this is very much an issue at the heart of this particular movement. So, what do you think? I'm going to leave you with those questions. I am very much looking forward to the discussion. Also, I will be posting a piece. I forgot to put it up earlier that discusses the utilization of CRISPR in do-it-yourself laboratories for animal research purposes and personal enhancement. So I'll leave you with that. I hope you have a great day, and I am looking forward to the conversation.